Hello, today we're going to talk about a method which is firstly used to factorize and solve quadratic equations, but then you will probably use it, for example, in complex numbers. And it's used both in the British system and in the IBs. Okay, it's called completing the square. So the main idea is to use what we call normally the perfect squares. I remind you that the perfect squares are a plus b equals a squared plus 2ab plus b squared, a minus b squared. And this second one is the same as the first one, but with a minus only on the second term. Third one is the same. And then there's the other one, which is a plus b times a minus b equals a squared minus b squared. This is often used in factorizing and in exams, but today we're going to look at the two others for the completing the square. Okay, if one of the terms of a or b is x, then we have, for example, x plus b squared will be x squared plus 2ab plus 2xb. Sorry, 2b. I'll write it like 2bx plus b squared. And then on the second one, x minus b squared equals x squared minus 2bx plus b squared. Okay, these are the two that we're going to use today. Okay. So what is completing the square? We can see it better in an exercise. Imagine that we have something like x minus 6x equals 3. Okay. And we're asked either to factorize the quadratic or to solve the equation. So of course we could do it if we write it as a normal quadratic expression, which is a good way to always write quadratics. We could of course solve it with the famous quadratic equation minus b plus minus the square root of b squared minus 4ac divided by 2a. But this is another method, and it's sometimes more useful. And then again, as we said, we can use it in complex numbers and in inequalities. Okay. So what are we going to do? We're going to try and use the first two perfect squares. Remember that the perfect squares are. It's a good idea if you learn these expressions, the red ones, because they come up often in your calculations. They save time. They make you do all the calculations faster and with less mistakes. Okay, so it's something that I recommend you to learn for your mathematics. Okay, so we want to either use the first or the second perfect square. How do we decide which one to use? Well, it depends on the second term in my quadratic and the sign of the second term. If it's a minus, I'll use the second one. If it's a plus, I'll use the first one. For example, in this case, it's a minus, so I'm going to use this one. Okay, so if I identify those terms, we immediately see that minus 6 is going to be equal to minus 2b, so 6 equals 2b, basically. Okay, so minus 6x equals minus 2bx. So basically 6 equals 2b. Okay, so b equals 3. Okay, so the quadratic I'm looking for is going to be x minus 3 squared. But there's a problem here. If I expand this quadratic with the red formula we have there, or the black one, I have x squared minus 2 times 3 times x. So that's 6x. And that's perfect. That's what I wanted to have. Okay. But then the last is 3 squared, which is 9. I don't really want this 9. I wanted to have a minus 3. So what do we do normally? What we do is we write the perfect square that we were looking for, x minus 3 squared, and then we subtract this number over here, whatever it is. So in this case, we subtract 9. I don't want it. Okay? And then I add the term I want. I want a minus 3, so I'll write a minus 3. Okay, so again, what do we do? First of all, we identify the perfect square we're looking for. It's the second one if it's a minus. From that term, we see which b we're looking for, which is in this case b equals 3. So our perfect square would be x minus 3 squared. But x minus 3 squared gives b squared, which is a 9. And I don't want it, so I basically subtract it, and then that way we will remove it. And I add a minus 3. So in the end, what I have is x minus 3 squared minus 9 minus 3, which is minus 12, equals 0. So this is what comes handy now, because x minus 3 squared equals 12. X minus 3 equals, I'm going to do the square root of both. The square root of the square and the square root will cancel out. And then always remember, when we do a square root, so when we move the index to the other side, when we do a square root, we have to write plus minus the square root. Never forget that you have to write plus minus. If you only write the plus, you're forgetting one of the answers, okay? Why? Because remember that square root of 4 equals plus 2 and minus 2, because 2 squared is 4 and minus 2 squared is 4. So it's always plus minus that square root, okay? So I can write this plus minus square root of 12 can be written as 2 squared, which is 4, times 3. And there's something you sometimes doubt if can be done, but if you have a squared times b, you can divide, if they're multiplying, you can divide that square root into 2 square roots. Okay, so this can be as long as it is dividing and multiplying, you can turn it into 2 square roots. If ever you have a doubt, for example, do the square root of something you remember, for example 4, which is the square root of 16, which you know is 4, and it can be written as 2 squared times 2 squared, okay, which is square root of 2 squared times square root of 2 squared, okay, bam 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 bam, and that is 2 times 2 is 4, which is correct. Okay, so I'm going to write it like that. I'm going to separate that. These cancel out. Plus minus 2 square root of 3. Okay, and then if we move the 3 to the other side, we have 3 plus minus 2 square root of 3, and that's our answer to our quadratic. Okay, so we've solved the quadratic expression by completing the square. We're going to do 1 or 2 more now, and with different difficulties, but as you see, it's very easy. And it not always is used to solve the quadratic expression, sometimes just to factorize, sometimes, as I said, to solve inequalities or whatever. But it is a very handy method to know. Another tool in your toolbox. Okay, so let's look at another example. Imagine we have x squared plus 8x minus 20 equals 0. Okay, so now let's follow the method I told you. Look at the sign. It's a plus, so it's the first perfect square. So the one we're looking for is x plus b squared, which is x squared plus 2x plus b squared. Okay, so 8 equals plus 2bx plus b squared. Okay, so obviously 8 equals 2b once we compare the second term and the second term. So b equals 4. So the perfect square we're looking for is x plus 4 squared. But x plus 4 squared, the last term is 4 squared, which is 16. I don't want it. I'm going to remove it. Minus 16. And then I'm going to add the one I want, minus 20, for my expression. So again, x plus 4 squared is x squared plus 4x plus 16. I don't want that 16, so I'm going to remove it. And then by doing this will only be x squared plus 8x, which is what I want here. And then I'm going to write the minus 20. Okay, so x plus 4 squared minus 36 equals 0. X plus 4 equals plus minus square root of 36, which is 6. I have moved the 36 to the other side as the plus 36. So I'll do this here just in case. And then I've done the square root, which gives me plus minus 6. So x equals minus 4 plus minus 6, which gives us two answers. X equals minus 4 plus 6, which is 2, and x equals minus 4 minus 6, which is minus 10. Okay? So this is the solution to the quadratic expression. Okay. So what happens if our second term is not an even number? So let's look at x minus 9x plus 14 equals 0. Okay? I've got no problem with that. I'll just, this is the perfect square I'm looking for. Okay? So minus 9 equals minus 2b. So b equals 9 halves. Absolutely no problem with that. So my quadratic is x minus 9 halves squared. And then the independent term is going to be 81 fourths. So I'm going to remove 81 fourths. And I'm going to add the 14 I want. So I'll work with it the same way as I would with an even number, even if it's an odd number. Okay? So, so now x minus 9 halves minus 81 fourths plus 4 times 4 is 16, 4 times 1 is 4, and 1 5. So if we do this, we have x minus, and that equals 0. So x minus 9 halves squared minus 25 fourths. Okay, so that's a 5, and then 8 minus 5 is 3, and 1, 2. Okay, equals 0. So x minus 9 halves equals plus minus the square root of 25 fourths. Okay, x minus 9 halves equals plus minus 5 halves. X equals 9 halves plus minus 5 halves, which gives us two solutions. X equals 7, 14 halves, and x equals 2, 4 halves. Okay? Which again is the solution to this. So if it's not an even number, it's an odd number, I'll just work with it the same way. I'll just have to work with fractions. And the last question which might arise is what happens if we don't have if we don't have a 1 in front of the term with the x squared. Okay, so for example, let's look at this example. Okay, so what happens here? Absolutely no problem. What I'm going to do is I'm going to factorize. So if I factorize this, I obtain 6 minus 2x plus 1/6. Okay, so follow me. If I multiply 6 times this, I get 6 squared minus 12 plus 1. So that's that. Okay, and then I work with the thing inside the bracket as I did before. So I need x minus 1 squared because minus 2 equals 2b, so b equals 1. 1 squared, I'm going to remove the 1 squared, and then I'm going to add 1/6. Okay, so I'm working the same as I did before. And then 6 times x minus 1 squared minus 1, the minus 6/6 plus 1/6 is minus 5/6. Okay, minus 6 plus 1 minus 5. Okay, so remember that when two things multiplied are equal to 0, we can solve them independently, a equals 0 or b equals 0, because if a is 0, whatever b is, the multiplication is going to be 0, and the other way around, when b is 0, I don't care what a is, the multiplication is going to be 0. So 6 can never be 0. Okay, so what we have to solve here is x minus 1 squared minus 5, 6 equals 0. So x minus 1 squared equals 5 sixths. X minus 1 equals plus minus square root of 5 sixths. X equals 1 plus minus the square root of 5 sixths. So that would be the solution. Also remember that if we wanted to expand this for whatever reason, we could get that another way to write this would be this. Okay, and then again, this can also be solved if we move the 5 to the other side and the 6 dividing, we again get this equation. Okay, so as I said, completing the square, something very useful to know. Very easy if you understand what you want to obtain, one of the perfect squares, how to obtain it, looking first at the sign of the second term, and then equating that second term to either 2bx or minus 2bx, depending on the one we choose. And then if you have something that is not a 1 in front of the x squared, just factorize and you get the same. Okay, hope it helps.